Hi, welcome to this lesson on calculus optimization problems. So what is an optimization problem? So differential calculus helps us to analyze different properties of a given function. One of its most useful applications is what we call finding extrema points. And that is the mathematical terminology to finding a maximum or minimum value of a given function. Okay, so let's have a look at an example. Norman rushes to put the kettle on as there is load shedding in 5 minutes' time. The temperature of the boiling water can be modeled by an appropriate function. So there's the power of functions. Okay, so the function is given as f of t equals negative 4t squared plus 40t, where t ranges between 0 and 9, and t is measured in minutes. So assume the kettle reaches its boiling point at 100 degrees Celsius. So f of t is measuring the temperature of the boiling water at any given time t. So we want to know three things. Firstly, will Norman have enough time to boil the kettle to its boiling point before load shedding hits in 5 minutes? What is the temperature of the water in the kettle after 7 minutes have passed from the time that we put it on? And what is the highest temperature of the water in the kettle? So let's see how calculus can help us find these solutions. So to check if the kettle will boil within 5 minutes, we need to check what the temperature will be at t equals 5. Okay, because that's interpreting what the function is saying. The function f of t was the temperature after a certain amount of time. So let's say Norman puts it on exactly 5 minutes before load shedding hits. Then in 5 minutes time, once the power goes off, what will the temperature of the water be? So if we plug it into that negative 4t squared plus 4t times t, we'll get negative 100 plus 200 equals 100 degrees Celsius. So that means if Norman puts it on exactly 5 minutes before load shedding, just as load shedding hits, he will have the temperature of the kettle at its boiling point. Great, so you can have his cup of tea. Okay, what about the temperature of the water at t equals 7 minutes? So this is what happens from the time we put the kettle on. 7 minutes later, how warm is the water in the kettle? So we plug that into the original function because the original function tells us the temperature at a given time. So if we plug in t equals 7, we get 84 degrees Celsius. I think that's still pretty warm, you could still enjoy your cup of tea at that temperature, but it'll be a bit cooler than usual, right? And then to find the maximum temperature, well, what we can do is set the first derivative of the temperature function equals to 0. So this is the general technique and methodology for solving an optimization problem. We're given a function and its maxima or minima, the extrema points, are either when it's maximum or minimum, depending on the function. And to find those, we use the first derivative equal to 0. So the first derivative, remember the function f of t was given as negative 4t squared plus 40t. So t is the independent variable here, time. So we derive with respect to t. So f prime of t using the power rule, bring down the 2, so it's negative 8 times t. Okay, 2 minus 1 is 1 in the exponent. And then 40t for the derivative is just 40. Okay, if we solve that equals to 0, we get t equals 5 minutes. So what does this mean? This means that the maximum temperature is achieved after 5 minutes of boiling. So when you plug in 5 back into the original function now, okay, we get 100 degrees Celsius, which again, that makes physical sense when you think about it. The highest the water is going to reach is when it reaches its boiling point, because that's when the kettle detects it reaches its boiling point, and the element says, okay, this is hot enough now, it's boiling, I'll turn off. So it doesn't exceed that temperature. Okay, so that's the maximum temperature of the kettle is its boiling point, again, which makes sense. All right, so that is the power of calculus to help us solve an optimization problem. Optimization, again, in summary, is finding the extrema points of a function, either the minimum or maximum values, that once you find it at that point, if you plug it back into the original function, you can see what the maximum or minimum based on the context is of the question. All right, so that's how we do this type of questions. I'll see you in the next one.